Gas laws, behavior of gases, chapter 14, a continuation of some of the things we discussed in chapter 13, specifically looking at gases. So let's start with properties of gases. Gases have low density. Density, as you remember, is equal to mass over volume. So we have the low mass over unit volume. They are compressible. Compressibility is the measure of how much the volume of matter decreases under pressure. So if we put a gas under pressure, the volume can decrease significantly. Gases exert pressure. They have mass, gas particles, and so when they collide with surfaces, they will exert pressure on those surfaces. Gases take the shape of their containers. They also take the volume of their containers. So when we describe a gas, we use 4 variables. So our pressure will be in kPa, atmospheres, or mmHg. Remember that 101.2 kPa is equal to 1 atmosphere is equal to 760 mmHg. Volume will be in liters, but any unit can be used actually. Temperature will be in Kelvin, and N is our number of moles. Okay, and these are important units that we use as we go through these problems. So, in relationship to pressure, let's look at the other variables. So, the amount of the gas, which is our N, right? Let's think about a bicycle pump. If we are using a bicycle pump to pump up a tire, right? As we increase the number of moles of gas that we put into the tire, we are increasing the pressure. And again, if we let the air out of the tire, as we decrease the number of moles of air in the tire, we are decreasing the pressure. Those are directly proportional. When one goes up, one goes up, the other one goes up. When one goes down, the other one goes down. Volume. Okay, so if we have a syringe, okay, and we increase the volume, that means that there is more space for those particles to move around, so they're not hitting the side of the container or each other as often, so we decrease the pressure. They are inversely proportional. One goes up, the other one goes down. And the same, if we decrease the volume, we increase the pressure. We're giving them less space to move around, so there are more frequent collisions. Temperature. The temperature is directly proportional to pressure. So if we put an aerosol can in the furnace or in a fire, please don't do this. It will explode. If we increase the temperature, we are increasing the pressure because those particles have more kinetic energy, have a higher kinetic energy. They're moving faster, and they're hitting the sides of the container or each other with greater force. Again, if we lower the temperature, we lower the pressure.